Okay, now we are going to solve practice problem 7.5 from Sadiku book. So the question is determine I0 and V0 for all t in the circuit shown in the figure 7.22. So this is the figure here. Assume that the switch was closed for a long time. So we will have two cases. The first one is when t is less than or equal to 0, when the switch is closed, and then we will have the second case. It is when t is greater than 0. So switch is open. And we will need to take a look this case one by one. Okay. Now let's take a look at the first case. The first case, which is when t is less than or equal to 0. Okay, so now when t is less than or equal to 0, the switch is closed. Switch is closed, and then it's closed for a long time, which is the circuit is now in DC condition, and in DC conditions inductor is short circuit. Okay, now we redraw the circuit to represent this condition. Okay, now we have the circuit that represent these conditions. So let's observe this circuit. So we will have short circuit here because inductor is in DC condition and the switch is closed. And now let's take a look at this node here. So because the inductor is shorted here, all the current will pass through this short circuit. So this resistance 3 ohm resistor will be useless, so we can just replace it with open circuit. So I can erase this, and now let's put the label again. So this is I0, and then this is I, and this one is V0. Okay, because this is parallel, all of this is V0. Okay, now let's pick this as our ground. So in our ground, our reference voltage is 0, so V is equal to 0, and I want to use KVL here at node A. So I will need to use KVL at node A. And KVL said that the sum of the current that goes in is equal to the sum of the current that goes out. The current that goes in is only this 24 ampere from current source, and then there are two currents that goes out. The first one is I0 and the second one is I. And I0 is V0 divided by 4. So I will have 24 is V0 divided by 4, and then I is V0 here divided by 2. So I can make all the denominator by 2, so I will have V0 divided by 4 plus 2 V0 divided by 4. Okay, now 24 is equal to 3 V0 divided by 4. Okay, now we can rearrange this into V0 is equal to 24 multiplied by 4 divided by 3. Okay, now 3 and 24 will be cancelled into 8, and so I will have V0 is equal to 32 volt. Okay, this is our first variable that we can find out, but this is when t is less than or equal to 0. So from here we can get I and I0. So I is V0 divided by 2, so I will have 32 divided by 2, which is 16 ampere, and I0 is 32 because VO divided by 4, 32 divided by 4, and that will be 8 ampere. Okay, 32 volt, 16 ampere, and 8 ampere. This is for our first case. Okay, let's save these three value because that will be important in the second calculation. Okay, now we need to take a look at the second case. The second case when t is greater than 0 or the switch is open. Okay, now this switch is open, so we can remove this current source, and we only have the right part of the circuit. So let's draw a circuit that represents that. Okay, now we have the circuit that represents when t is greater than 0. And I have put the label, so this is the I0, and this is the I, and that is the V0. Okay, now let's observe what can we get from this circuit. So now we will have 4 ohm in series with this 2 ohm, and then they are in parallel with this inductor and this 3 ohm. So we can replace the resistor with a single resistor, which is the value is R is equivalent to 3 parallel with this one, 2 and 4. 2 and 4. So I will have 3 parallel with 6, and that will be 3 multiplied by 6 divided by 3 plus 6, or 3 multiplied by 6 divided by 9, and 3 and 9 will cancel into 3, and that will be 2 ohm. 2 ohm. And so let's redraw the circuit here into this one. So this still be 1 Henry, and this will be in series with this our equivalent resistance here, which is 2 ohm. Which is 2 ohm. And if we put the label here, we can only use I here, because I0 is different current and V0 is different voltage. Okay, now we need to do analysis on this RL circuit. So we need to do KVL here. So I will have named this loop as loop I because the current is the same. So let's do KVL at loop I. So I will start at this resistance. So KVL said that the sum of the voltage is 0, and the voltage in this resistor is 2 multiplied by I. And then in the inductor, remember that inductor formula is V is equal to L di over dt. And then L is 1 Henry, so I will just plug 1 into that formula. 1. and then di over dt, that will equal to 0. And because this is 1, I just remove this one. Okay, now I will have di over dt is equal to 0, or we can rearrange this as di over dt is equal to minus 2i. So now we have this one, this differential equation, and our whiteboard is full. Let's see what can we do next. Okay, so far we have this differential equation. So I did not erase this circuit because this will be useful later. So I will solve this differential equation. Di over dt is equal to minus 2i. And we need to use separation of variables. So I will isolate I to the left hand side and t to the right hand side. So I will have di over I is equal to minus 2 dt. And we can integrate both sides. And then integral di over I is natural log of I is equal to minus 2t plus some constant. Okay, so we can rewrite this as I is equal to e to the minus 2t plus c1. Okay, this is a function of time, so let's rewrite this as a function of time. Or we can rewrite this as it is equal to e to the minus 2t multiplied by e to the c1. Okay, because this is also a constant, let's name this as k. So we can rewrite this as it is equal as k e to the minus 2t. Okay, now we have this one. We need to find the k. Okay, what do we know here? We have the initial condition here. So when t is less than or equal to 0, I is 16. So that means that I0 is equal to 16. So I0 is when 0 is inputted into this function. So I will have k e to the minus 2 multiplied by 0 is equal to 16. And e to the 0 is equal to 1. So I will have k is equal to 16. So finally, I have it is equal to 16 e to the minus 2t for t greater than 0. Okay, so now we still have a homework to find I0 and V0. I is already found. Okay, let's see what can we do. Okay, now we still need to find I0 and V0. So first, I want to find the voltage across this inductor. This will be very useful. So I will have this one plus minus, and this is the voltage across this inductor. So let's name this as node A and let's name this as node B. From the inductor formula, we know that we will have this is L di over dt. And then L is 1 Henry, so I will have 1 and multiplied by d over dt of this one, right? 16 e to the minus 2t. And 1, we can just remove this. And then d over dt of this one is minus 2 multiplied by 16 e to the minus 2t. So I will have VL is minus 32 e to the minus 2t. Okay, now let's see here. This is VA and VB. It is parallel with this inductor is parallel with this resistor here. So the voltage across this one is also VL. So we can just use Ohm's law to find out the I/O. Okay, I/O is just this voltage here, VL, divided by the resistance value. The resistance value is 4 plus 2. 4 plus 2. And so we can just input our value here. So minus 32 e to the minus 2t divided by 6. So I/O of t is equal to, this one will be, okay, 32 divided by 6. Okay, 5.33. So I will have minus 5.333 e to the minus 2t ampere. So this one for IOT. So the last one we still need to find the V0. Okay, let's save this and erase the whiteboard. Okay, so lastly we still need to find the V0. And here we have the current that flows through here, and the current is the same as I0 because this is a series circuit. And so we can find V0 by using Ohm's law. So V0 is, because this is flowing from the negative to positive, the value will be minus. So I will have minus I0 multiplied by the resistance, which is 2. And I0 is this one. So I will have minus 5.333 e to the minus 2t multiplied by 2. And this one will be minus 10. Not minus, because this is minus and minus, they will cancel each other, so the value will be plus. And so I will have 10.667 e to the minus 2t. So this is our V0, and that is a function of time, so I will write this as V0 as a function of time. So I finally have V0 of t is equal to 10.667 e to the minus 2t. Okay, now let's draw a conclusion of our calculations. So I will have our conclusions. So we have two piecewise functions, so I will have I is 16 ampere when t is less than or equal to 0, or 16 e to the minus 2t for t greater than 0. And then I/O is equal to, here, eight ampere, and then IOT is minus 5 minus 3 e to the minus 2t. This is for t less than or equal to 0, and this is for t greater than 0. And then lastly we have V0. V0 is 32 volt for t is less than or equal to 0, or 10.667 e to the minus 2t. So t is greater than 0. So thank you for watching. Hopefully I did not make any mistakes. Do not forget to like and subscribe. Thank you.